Hello everyone, my name is Yaroslav Golubev. I'm a researcher at JetBrains Research, and I would like to present to you our study of potential code borrowing and license violations in Java projects on GitHub. What are the origins of license violations in open source? Firstly, developers very often reuse others' code. The main reasons include the desire to skip the universal and trivial parts of functionality and focus on the relevant part of code, and also financial and temporal constraints that are very often present in the open source software. Secondly, there are a lot of misconceptions about licensing. Open source software is not necessarily free to reuse and modify unconditionally, and even if a developer pays attention to the licenses, there are so many of them that anyone would get really overwhelmed. This figure presents the most famous and popular licenses. It is safe to say that most of the developers have encountered almost all of them in their work, but not all the developers pay close attention to the differences between them, especially to the difference between permissive licenses and copyleft licenses that require the derivative work to also have the same license. To study the potential violations, we propose the following pipeline. Firstly, we collect the data in the form of projects with a full version control system history. Then we detect clones in this dataset on the method level and extract all code blocks from inter-project pairs. For each block, we gather its license and its last time of modification, and therefore we can hypothesize from where to where the code fragment might have migrated and whether the licenses allowed for it. Having this information for all the pairs allows us to perform the general analysis. Which licenses are the most popular? What are the most frequent borrowings? Which licenses are potentially the most violated? And how many code fragments come from restricting licenses? A lot of research has been recently conducted in this area. On this slide we list some of the most interesting studies that involve looking for clones in large code bases, licenses and their distribution, and a combined study. You can find more detailed description of the studies in our paper. Our dataset was based on the public Git archive, which lists all GitHub projects with at least 50 stars as of early 2018. In our study, we chose Java as the target language because of its popularity in industry. The final dataset consists of more than 23,000 Java projects with their histories downloaded on June 1st, 2019. We also used GitHub API to get the list of forks of the projects and identify fork pairs in the corpus. Public Git archive also provides a license for each of the repositories detected by the authors of the corpus using Go license detector. The full list of projects is available at this link. First of all, we detected clones in the collected projects using the Sorcerer SC clone detection tool. The main search was conducted with a similarity of 75% and the minimum size in tokens of 19 to filter small and trivial pieces of code. We also searched for larger duplicates with less similarity and then merged the results. Additionally, we also conducted a separate search at 100% similarity to find exact clones of code. Even though public Git archive lists the licenses for projects, very often big projects have files with different licenses in them. To determine the licenses of specific files, we use Ninka, a tool that parses the header of a file and outputs its guess of its license. We then looked through all the variants of the output manually, verified them, and fixed discovered inconsistencies. In general, we consider the code fragment to have the license of its file. If the file has no license, we consider it to have the license of the project. And if the project also has no license, then it falls under GitHub's terms of service. As for the date of the last modification, we ran git blame command on all of files and got the time of the last modification for every line. In this example of two blocks, darker color indicates more recent lines of code. Even though, as a whole, the block on the right was modified more recently and Git would show the file to be modified more recently. From the standpoint of possible borrowings, it makes more sense to consider the block on the left to be more recent. Therefore, for each block, the date of its last modification was the most frequent date of the last modification of its lines. Having this information, we conducted the analysis. Firstly, we gathered the distribution of licenses among files. Then, to study possible borrowings, we filtered out the following clone pairs: forks, discovered mirrors, and projects from the same user or organization were not considered as possible code borrowings. Then we transformed the remaining pairs into license pairs, for example, from Apache to MIT. Then we ranged the license pairs by their popularity and labeled them manually as either permitting or prohibiting borrowings until we covered 99% of all detected duplicates. In this labeling, we assumed all the best case conditions: the presence of the copyright, the presence of the license text, etc. The following license pairs were considered prohibited. Firstly, unbeknownst to a lot of developers, simply uploading code to GitHub doesn't make it open source. You cannot copy unlicensed code on GitHub without explicit permission of the author, and similarly, you cannot remove the existing license from the code. Also, you cannot copy from copyleft licenses to permissive licenses. Finally, there are unique incompatibilities between certain licenses, like for example the prohibition to copy code from Apache 2.0 to General Public License 2.0. The final analysis consisted in studying individual blocks of code. Considering the fragment's direct predecessors and successors, its older and younger clones, respectively, several combinations are possible. Here, a solid lines mean prohibited borrowing, and a dotted line means a permitted borrowing. The safe blocks are unique blocks that have no clones at all, blocks that only have younger clones, they cannot be a product of a violation, or blocks all predecessors of which are permissive. The blocks of interest from the standpoint of possible violations are blocks that have some of their predecessors come from a prohibiting licenses, and especially those that have all of their predecessors come from a prohibiting license. Let's get to the results of our study. Overall, the tokenization resulted in 38.6 million blocks of code, 11.8 million of which passed the size threshold of 19 tokens and were searched for clones. Of them, 64.6% engaged in some sort of cloning. The search took 66 days of computations and yielded 1.2 billion clone pairs, of which almost half consisted of clones between different projects. Overall, in the analyzed files, a total of 94 different licenses were detected. As can be seen, they are very unequally distributed. A full list is available, you can use the QR code for the link. Let us take a closer look at the most popular licenses. As you can see, the linear scale reflects the situation much better than the logarithmic one. The most popular license by far is Apache 2.0, that covers more than half of all files. Second is not a license, but as previously mentioned, its absence. The presence of such a large amount of unlicensed code, coupled with the popularity of code reuse, can surely pose a real problem. The next three licenses include more very well-known licenses: permissive MIT and BSD 3 clause, and a copyleft General Public License 3.0 or later. A lot of licenses fall into the same family. The most important such family is probably GNU, General Public Licenses. Not only are they strongly copyleft and therefore require even closer attention, they're also very dependent on their version, especially their compatibility. They are very prevalent in the list of most popular detected licenses and together make up 12.6% of all files, fewer only than Apache 2.0 and no license. A very different family is the family of BSD licenses. There are even more of them in the dataset, but only two of them are relatively popular: the 3 clause version, very popular, and the 2 clause version, less popular. The remaining ones are some small variants. The most diverse family, however, are Creative Commons licenses. Interestingly, even though these licenses are not very present in our corpus, Stack Overflow is licensed under Creative Commons Attribution Share-alike license, so the developers should pay attention to them. Another interesting case to look at is multi-licensing. In this case, we mean several licenses within a file. In our corpus, less than 1% of files have several licenses in the header. There are 74 different combinations of 2 licenses, with 2 being much more common than all others. The first combination is Common Development and Distribution License and General Public License 2.0 with class path exemption. that is most often used in the projects and derivative work of Sun Microsystems and subsequently Oracle. Another combination is Apache 2.0 and General Public License 2.0 or later. There are also 8 different combinations of 3 licenses, with the most prominent being present on the slide. It is even presented in the files as a unified marked block, and one file in the entire dataset even had 4 licenses in the header. After filtering out forks, mirrors, and projects from the same users, the remaining clone pairs were considered to be possible borrowings. Among these pairs, 11.7 were exact clones, which is quite a lot. Also, as you can see, the distribution of possible borrowings is just as extreme as the licenses themselves. More than half of all potential borrowings fall within Apache 2.0. On the right, you can see a heat map of potential borrowings within the most popular licenses. An interesting feature of this map is its relative symmetry. The number of possible borrowings from A to B and borrowings from B to A is at least similar. There are no significant differences. That might indicate that the amount of possible borrowings between licenses is generally dependent only on the popularity of the licenses. And if the code is being copied between projects, the developers do not pay much attention to the licensing. After the license pairs that cover 99% of all clone pairs were labeled, 73% of potential borrowings turned out to be permitted, and another 27% turned out to be prohibited. The figure on the left shows the most violated licenses, that is, licenses that cover the most blocks that are possibly copied with violating this license. It can be seen that still the majority of possible borrowings violate the rights of developers that did not license their code. Figure on the right shows the most violating licenses, that is, licenses that cover blocks that are possibly copied with a violation of the original license. Here, Apache 2.0 and GitHub together make up 84% of all receiving cases due to their popularity. In both cases, it is important to note that there is a large amount of unlicensed code that poses a problem and is being violated. Finally, we studied the possible origins of specific blocks. This means accounting for all the possible places from where every block could be borrowed from and drawing up the relations. You can see the results on the figure. 35.4% of blocks have no clones at all. 35% more of blocks have only clones within the project, their author, the fork or a mirror, but not to any unconnected projects. 8% more of blocks have such clones, but all of them are younger than this block, meaning that this block can only be the source of the borrowing or a violation, but not its product. Another 1.8% fall on the borderline case. These blocks only have clones with the same last date of modification, so we did not consider them. 10.4% more have clones in unconnected projects, but all their older clones come from permitting licenses, and therefore there are no violations. The remaining blocks present the real interest for us. 5.4% of blocks constitute weak possible violation, meaning that some of their older clones come from prohibiting licenses, and 4% constitute strong violation, meaning that all of their older clones come from restricting licenses. This amounts up to 500,000 code fragments. Let us reiterate the main results of the study. From hundreds of millions of clone pairs in Java code on GitHub, approximately half come from different projects. A total of 94 licenses were discovered in the corpus. They are very unevenly distributed, with the most popular ones like Apache 2.0, MIT, BSD, 3-clause, General Public License having top places. At least 9.1% of files in the dataset have no license at all, which might pose a problem because of their legal status. Just under 1% of files have multiple licenses. When talking about possible borrowings or clones from the standpoint of licenses, half of them fall within Apache 2.0 because of its popularity. Unlicensed code is the most probable to be violated. This might be the most important practical conclusion of this study. Developers should pay strict attention to unlicensed code and know that they cannot take it without explicit permission. As for the blocks of code themselves, 35.4% have no clones at all, and 9.4% might constitute license violations, of them 4% strongly. On this slide, you can find links to the paper with more details and also to more work by our research group. If you have any questions or suggestions, feel free to contact me at the given email, and thank you very much for your attention.